The universe is so large that our brains struggle to truly understand its scale. Our galaxy alone contains hundreds of billions of stars, and modern astronomy suggests that many of those stars likely have planets orbiting them. Now, when you expand that idea across billions of galaxies, the numbers become almost impossible to imagine. From a statistical perspective, intelligent life should not be rare. In fact, many scientists believe the universe should be full of advanced civilizations. So this creates one of the most important questions in modern science. If intelligent alien civilizations are common, why do we see absolutely no evidence of them? No signals, no spacecraft, no massive engineering structures? Nothing. This mystery is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked a very simple question: where is everybody? And the more we study the universe, the stranger this silence becomes. Because if even a tiny fraction of civilizations became technologically advanced, some of them should have spread across the galaxy long ago. But when we look into space, the universe appears completely silent. And that leads to a disturbing possibility. Maybe civilizations do appear throughout the universe, but something prevents almost all of them from surviving long enough to become truly advanced. In other words, the silence may not be random. It may be a warning. To understand the Fermi Paradox, scientists began considering a disturbing possibility known as the Great Filter. The basic idea is simple. Somewhere between the birth of a planet and the rise of a galaxy-spanning civilization, there is a barrier so difficult that almost no species ever passes it. That barrier is called the Great Filter. Now, think about the chain of events required for intelligent life to exist. First, a stable star system must form. Then, planets need the right chemistry, liquid water, and long-term environmental stability. After that, simple life must appear. Then, life has to survive extinction events for billions of years while evolving into complex organisms. Eventually, intelligence must emerge. And finally, that intelligent species has to survive its own technology. At every step, civilizations can fail. A planet can become unstable. A nearby supernova can sterilize an entire solar system. Climate collapse, nuclear war, engineered pandemics, uncontrolled artificial intelligence, or resource exhaustion could destroy a civilization before it ever reaches the stars. And physics makes this problem even worse. Space is not designed for easy survival. The distances between stars are enormous. Even traveling at the speed of our fastest spacecraft, reaching nearby star systems would take tens of thousands of years. Interstellar colonization may simply be far harder than science fiction usually assumes. Some physicists even argue that advanced civilizations naturally consume more and more energy until they destabilize their own planet. In other words, intelligence may contain the seeds of its own destruction. And if that is true, then the silence of the universe starts to make sense. Because civilizations may not disappear by accident. They may disappear because the laws of physics make long-term survival extraordinarily difficult. At this point, scientists begin dividing into two major camps. One side believes biology is the real bottleneck. The other believes physics is. The biological argument says that intelligent life may be incredibly rare. Yes, planets might be common, but the conditions required for complex life could be extraordinarily unlikely. On Earth, life appeared relatively early, but for nearly 3 billion years, life remained simple. Complex multicellular organisms appeared surprisingly late. An intelligent technological civilization emerged only in the very last fraction of Earth's history. Some researchers argue this means evolution toward intelligence is not inevitable at all. In other words, planets filled with bacteria may be common, while civilizations capable of building radio telescopes could be almost non-existent. But others think biology is not the problem. They argue that once life begins, evolution naturally pushes toward increasing complexity and intelligence. Instead, they believe physics creates the true barrier, because the universe itself may simply be too hostile for civilizations to survive long term. Space is violent. Stars explode, planets freeze, asteroids collide. Gamma ray bursts can release more energy in seconds than our sun produces in its entire lifetime. Even worse, advanced civilizations may create dangers faster than they solve them. The more technologically powerful a species becomes, the greater its ability to destroy itself. A primitive civilization cannot build nuclear weapons. It cannot engineer artificial pandemics. It cannot create autonomous, superintelligent systems. But an advanced civilization can. This creates a terrifying possibility. Technological progress may increase extinction risk faster than wisdom evolves. And if that pattern is universal, then intelligence itself may be unstable. Civilizations rise, they become more powerful, and eventually, many may destroy themselves before ever reaching interstellar scale. So the real battle may not be biology versus physics. It may be whether intelligence can survive its own success.
But there is another possibility. Maybe the problem is not life. Maybe the problem is reality itself. Some physicists have proposed a far stranger explanation for the Fermi Paradox. What if we live in a multiverse? The multiverse idea appears in several areas of modern physics. In some models of cosmic inflation, space may continuously generate new universes with different physical conditions. In quantum mechanics, certain interpretations suggest reality branches into multiple outcomes. And in string theory, there may be an enormous landscape of possible universes, each with different laws of physics. Now, here is where things become interesting. Most universes may be completely hostile to complex life. Some might collapse too quickly after forming, others may never produce stable stars. In many universes, chemistry itself may not work in a way that allows biological complexity to emerge. Even tiny changes in fundamental constants could make life impossible. For example, if gravity were slightly stronger, stars might burn too quickly. If it were slightly weaker, stars and galaxies might never form properly at all. The same is true for electromagnetism, nuclear forces, and the expansion rate of the universe. This creates what physicists call the fine-tuning problem. The laws of our universe appear strangely balanced in a way that allows matter, stars, planets, chemistry, and eventually life to exist. So one possible explanation is that we exist in one of the very rare universes where observers are even possible. In other words, maybe most universes are silent because they are dead from the beginning. And maybe our universe is not typical. It may simply be one of the few places where complexity survives long enough to ask questions about itself. But the multiverse idea leads to an even darker thought. If universes themselves vary in how easily civilizations survive, then perhaps we exist in a universe where intelligence is naturally unstable. A universe where civilizations repeatedly rise and disappear. If that is true, then the silence around us may not be temporary. It may be built into the structure of reality itself. At this point, the Fermi Paradox stops being just a question about aliens. It becomes a question about us. Because if a great filter exists, then humanity must fall into one of two possibilities. Either the filter is behind us, or it is ahead of us. If it is behind us, that means the emergence of intelligent life is unbelievably rare. Perhaps the transition from simple cells to conscious technological civilization almost never happens. In that case, humanity may already be one of the rarest phenomena in the universe. But if the filter is ahead of us, the implications are far more disturbing. That would mean advanced civilizations repeatedly reach a certain level of technology and then fail. Maybe they destroy their environment. Maybe they create weapons powerful enough to eliminate themselves. Maybe artificial intelligence becomes uncontrollable. Or maybe civilizations simply collapse under the complexity of their own systems. What makes this idea unsettling is that humanity is now entering a period where many of these risks are becoming real simultaneously. Nuclear arsenals still exist. Artificial intelligence is advancing rapidly. Climate systems are becoming increasingly unstable. Biotechnology is becoming more powerful and more accessible. For the first time in Earth's history, one species has gained the ability to permanently shape or permanently end its own future. And this changes how we should think about the silence of the universe. Instead of asking, why is nobody out there? We may need to ask, what happened to them? Because the universe does not appear crowded with ancient advanced civilizations. It appears quiet, almost as if intelligence repeatedly reaches a dangerous threshold and rarely survives beyond it. Which means humanity may currently be carrying the most important stage in its entire history. Not the moment we become advanced enough to explore the stars, but the moment we prove that intelligent civilization can survive its own power.
The Fermi Paradox began with a simple question. If the universe should be full of intelligent life, where is everybody? But after exploring the great filter, the fragility of civilization, and the possibility of a multiverse, the silence no longer feels mysterious. It feels meaningful. Maybe intelligent life is extraordinarily rare. Maybe advanced civilizations almost always destroy themselves. Or maybe the universe itself is structured in a way that prevents long-term survival. We still do not know the answer, but one thing is becoming increasingly clear. The universe is not simply a place of endless possibility. It may also be a system filled with invisible limits, and humanity may now be approaching one of them. For most of history, survival depended on nature. Today, survival increasingly depends on whether intelligence can manage its own power responsibly. That may ultimately determine whether civilizations disappear or continue long enough to reach the stars. And this brings us back to the terrifying silence we started with. Across a universe billions of years old, we do not see evidence of ancient galactic civilizations. We see darkness, silence, empty space. And perhaps the most unsettling possibility is this. The silence is not telling us that life never existed. It may be telling us that survival is far harder than intelligence. Which means the greatest challenge facing humanity may not be discovering alien civilizations, but making sure we do not become another lost civilization that the universe quietly erased.